Okay, so the next speaker is a student of mine for my general chemistry course. It's on chemistry, cavities, and crowns. Please welcome Mathew Jones.
So my name is Mathew Jones, and I get to talk about teeth, which should excite you. We'll start with an overview of what we'll kind of go over. We'll just kind of break down how teeth demineralize, how they remineralize, the effect that fluoride has on the enamel structure, and just restorations, which can be dentures, that can be crowns, fake teeth. So we'll start with George Washington. Few people know that before George Washington crossed the Delaware, he was trying to be a dentist. That's not true. George Washington is just a good example of somebody that never smiles. And if you see his teeth, you see why he never smiles. So it's supposed to be like wood and ivory. And those are awesome. So we have the solubility of teeth. You can see the enamel structure, which is the calcium, the phosphate, the hydroxide. In acidic solutions, it breaks down into calcium, phosphate, and hydroxide. It's a dynamic equilibrium, so this is always taking place in our mouth. The enamel is breaking down, it's eroding, and then it's also remineralizing to an extent. You know, if you lose like half your tooth, it's not going to come back, but you want to try to maintain that balance, that equilibrium, so you don't lose your teeth. Because you only get like one set of teeth. Like your body doesn't start producing more teeth when you get older. This just kind of explains that point that I was just making. Saliva is important because it's a buffer in our mouth. So what happens is when that calcium and phosphate ions break down in our mouth, they interact with our saliva. So if you don't have saliva in your mouth, you see that breakdown take place at a greater rate. So people that don't have a lot of saliva, like if you have dry mouth or drug users, you see their teeth break down a little bit more. The plaque's important because that's where the acid's produced that breaks down our teeth. So like when people say that sugar's bad for you, they're saying that the plaque consumes that sugar to form the acids. We don't really go into that process. This is more just about kind of the acidic food and the breakdown of the teeth. The critical pH of an enamel is 5.5, so that's the pH where it's saturated. At a low pH, the minerals dissolve as we have the teeth eroding. So this is a table that shows kind of the acidic foods that we eat. Going back to that solubility product, you see the calcium, the phosphate, and the fluoride all play a role in preserving the teeth. So the more calcium or the more phosphate the food that you eat has, the less likely they are to break down. So yogurt is a good example because yogurt has a pH of 4.3, so it's less than that critical pH of 5.5, but it has such a high concentration of calcium and phosphate that we don't think of it as really like eroding our teeth. Red Bull is kind of a newer one. All those energy drinks are going to be acidic. Pepsi Cola, obviously. Coffee, so coffee's above the 5.5 threshold, so it doesn't break down. It's more just stains, I guess. This is kind of an example of the effect that fluoride has on the tooth structure. So what happens when we ingest fluoride in our mouth is the fluoride takes place at the hydroxide. And you can see the fluoride has a bigger structure than the hydroxide, so it's less likely to be penetrated by the chemicals, by the acids that are going to dissolve the teeth. It's going to make it more dense. It's going to make the tooth more dense. So now we'll kind of go over some of the restorations. Like the first one is Mercury Amalgam. This is a kind of a controversial one. People associate mercury with like dangerous vaccines, or they find mercury on the brain of Alzheimer's patients. So that mercury is characterized by that silver color. The amalgam just means it's an alloy. So you're going to have the mercury, you're going to have the silver, and the tin. It's a liquid at room temperature, and then when you mix it with those other metals and cure it, it forms a solid. You don't see these as much anymore, just because they have a composite resin that actually looks like a tooth. It seemed like that was kind of hard to get introduced because the mercury is so hard and it lasts a long time. It's very durable, it doesn't leak, but there are those potential dangers with it. Most of the time, the danger is when you put in a filling or when you take out a filling. It's crazy that the average American adult has 8 fillings. It's wild. So we have the restorations. There are different types of crowns. An all-ceramic crown is going to be a zirconium oxide, so think of it as like glass. The porcelain fused to gold, so that's when you stack porcelain on like a gold crown or like a palladium or platinum crown. Gold is used because it's a noble metal, so it's real stable, it doesn't corrode, it's biocompatible. Some of the other metals that we'll see would not be a good fit in your mouth in that grow environment. So this is an impression. This is kind of the first step in creating a crown. We kind of go over this process just to explain, why we use certain metals. So this is an impression that I got yesterday at work that I thought I'd show you. From the impression, we can make a stone model. So that's like a stone model. It's made of gypsum, which is calcium sulfate dihydride. So you mix it with water. It's an exothermic reaction. It expands and it forms a model. From the model, you create a wax pattern. So basically you're painting wax onto that tooth, and you're creating a mold of what the crown's going to look like. This process is similar for jewelry, so if teeth don't get you excited, think about rings and bracelets and everything. So you can make a wax pattern for jewelry too, and cast it the same way that you would a fake tooth. So once you have a wax pattern, you invest it. And what the investment material has to withstand the molten metal that gets poured into the mold. So it's kind of hard to picture what it looks like from this picture, but in this one you can see that the investment material surrounds the crown. You can see where there's a space, an area for the molten metal to kind of flow in and create that metal crown. So this is the casting procedure. Once you have that mold from the investment, you pour the molten metal inside that investment, and you put it into a casting machine. It creates the metal crown. The casting machine works like this. Is kind of an old example, just because they're using a torch. A lot of the new technology has machines where they create a pressure vacuum. The pressure vacuum sucks the metal into the mold. Then you just have to let it cure and set. So that's your finished product, which is very blurry, but you see a gold crown that looks like probably a platinum or a silver one. So chemistry is involved in both the breakdown of the teeth and kind of how we find a way to replace them, which is a lot better, I think, than those George Washington's dentures. These are the metals that are used for metal crowns. The high noble alloys are going to be mostly based on gold, the noble metals. Base metals are nickel, cobalt, titanium. Nickel is the most common metal allergy, so people with metal allergies wouldn't necessarily want a nickel-based crown. They say the base metals can corrode a little bit easier than the high noble alloys, which are gold, palladium. And the high noble alloys are obviously going to be more expensive than base metal. The thing about these two is you have that metal that forms the base of it, so light doesn't pass through it. So it's not as translucent as like a glass crown. So they say that they don't look as much like teeth as like a ceramic, like a zirconium oxide, like a glass crown would. So it's more translucent. So the future, we'll talk about like the future of chemistry and dentistry, and this picture kind of just shows that there isn't much future in dentistry because a lot of it's going digital, or much chemistry in dentistry. So what happens here is the dentist or the dental assistant will use an intraoral scanner to create a 3D model of your mouth. From there, you can send it to like a 3D printer, or you can send it to a designer, I guess like a tooth designer. The tooth designer can do like the CAD/CAM software to digitally create a 3D crown. They say that this method is more accurate than the casting and the impressions and everything, because you have the expansion and you have human error too when you're creating the crown. You have to make sure you hit the right temperature, you have to make sure you have to use the right stone, things like that. So from here, once it gets designed and scanned, they actually send it to a milling machine where it can be milled, as opposed to the casting procedure that I showed. The mills are repurposed auto parts machines. So they just put it in a mill, and it takes like 30 minutes to make a crown, whereas the process that I kind of showed you before takes a lot longer. So the conclusion is, make sure you brush your teeth, I guess. Yeah, because that fluoride's important, especially like at night. You don't want to like eat anything or drink like soda after you brush your teeth. You want the solution, the saliva, the calcium in your saliva to kind of remineralize, help maintain the tooth structure. Just because that enamel is the hardest structure in the body, so you hate to lose it. And yeah, that's it. Yes?
Scanner of the future, what is the cost? Is there a difference in cost?
Between the final product or with the cost of the
The
scanner?
whole process, I mean, is one process more expensive?
So the zirconium oxide is cheaper than it would be to buy like a gold alloy. The scanners themselves are about $40,000, and you have to consider the mill. Mills can be between $50,000 and $80,000. So yeah, so some of the dentists will have the mill and the scanner in their offices. Some of them it's just too expensive. You don't want to know about the final cost between what it costs to make it and what the dentist charges you. You're better off not knowing that. But I mean, yeah, there is a difference between the costs. It's not as big of a difference as you would think.
I have another question. So what you said about our saliva, then maybe it's not so good to use mouthwash either at night.
Mouthwash
With
is
alcohol, when that.
it's sodium fluoride. Is what I've seen most of the mouthwashes are. I don't know that there's a ton of benefit from mouthwash because it doesn't have that abrasive material like a toothpaste would. It doesn't kind of scrub off that plaque, but I guess it's a good, if you have mouthwash, might as well use it. I guess it's not going to do any harm to your teeth.
Very good.
Cool, thanks.